Hello, this is Mrs. White, and I will be talking about the seasons. Now, our essential questions for this lesson is what causes day and night, and what causes the seasons to change. So we'll start first with the summer in the Northern Hemisphere. So as you can see in the diagram, on the left-hand side, the Northern Hemisphere is tilted towards the sun. Hence, it is the summertime on the Northern Hemisphere. Now, the sun is mostly direct, or the light is actually focused in the northern or upper part of the earth, and there are longer days and shorter nights, as well as the North Pole having a constant daylight. Now think about this question: how is the Northern Hemisphere tilted during the summer? The next one is fall in the Northern Hemisphere. Now, the axis is not pointed towards or away from the sun. Now, there's equal amount of sunlight in both hemispheres, the northern and the southern part. The next one is your winter in the Northern Hemisphere. Now, the Northern Hemisphere is tilted away from the sun, as you can see in the diagram, and there are shorter days and longer nights. And the South Pole this time is now receiving constant daylight. Now, my question is, how is the Northern Hemisphere tilted during the winter time? Next up is your spring, Northern Hemisphere. Now, as you can see in the diagram, the axis is not pointed towards or away from the sun. Now, there's equal sunlight in both hemispheres, north and south. Now, there are equal lengths of day, which is 12 hours, and nights, which is also 12 hours at the equator. Now, let's now go to the Southern Hemisphere. Let's take a look at the seasons. Now, the seasons in the Southern Hemisphere are pretty much the opposite of the Northern Hemisphere. For example, if it is summer in the Northern Hemisphere, such as, let's say, in Dallas, Texas, it is winter in the Southern Hemisphere, such as in Rio de Janeiro. Now, here's a question. If it's fall in the Northern Hemisphere, what season is in the Southern Hemisphere? Let's talk about the solstices. Now, solstices, the longest or shortest days of the year. That's what it meant. Now, the sun usually reaches its highest or lowest point in the sky. Now, the summer solstice is about June 21st, and the winter solstices is about December 21st. My question is, how far apart are the summer and winter solstices? Now, let's take a look at this diagram here during the summer solstice. Now, as you can see, the axis, or the earth, is tilted towards the sun. And as you can see, in each part, in the Arctic Circle, there's 24 hours of daylight. The Tropic of Cancer, just a little bit below, there's 13.5 hours of daylight. In the equator, there's no change, so there's equal amount of daylight and dark. And then as you go down in the Southern Hemisphere, you can see that there's 10.5 hours of daylight, while at the very bottom part of the earth, which is the southernmost part, which is the Antarctic Circle, there's no daylight at all. Now, how about the winter solstice? Now, the winter solstice, if you can remember and recall, that the tilt of the earth is away from the sun. Now, as you can see here, that the Arctic Circle is now receiving 24 hours of darkness, no light at all. For the Tropic of Cancer, there's about 13.5 hours of darkness. In the equator, there's 12 hours of darkness, so it's equal day and night. And for the Tropic of Cancer, on the southern part, there's about 10.5 hours of darkness. And in the Antarctic Circle, there's no darkness at all. Now, what are equinoxes? Now, the equinoxes, the day and night are pretty much equal at the equator. Now, the vernal equinox is about March 20th, and the autumnal equinox is about September 22nd. Now, take a look at the image here. Based on the image, what is the other name for vernal equinox? All right, let's just summarize what we learned today. We learned about the seasons, when different seasons in the northern and southern hemisphere. And we also talked about equinoxes, and solstices. Now, I'd like you to give your best answer to this. Describe the season in the northern and southern hemisphere at each location. Now, you're going to use this diagram right here, A, B, C, and D, and describe the seasons in the north and south hemisphere for A, north and south hemisphere for B, north and southern hemisphere for C, and northern and southern hemisphere for D. And I will see you in class. Bye.